Okay, so what we're doing here is we're going to look at a couple of different scenarios. Scenario number one is student drops a ball off the top of the building and records the fall, that it takes 2.85 seconds to reach the ground, determine all unknowns, and answer the following questions. Neglect the drag. So in all these kinds of situations like this, we're going to look at what happens with how do we find the ball speed just before it hits the ground, and then what height was the ball dropped. So we don't know H, question mark, and we don't know V final, question mark. Okay, but we do know a few things, and the few things we do know, we need to read the original prompt, and then make a list. Student drops a ball off the top of a building and records that the ball takes 2.85 seconds. So my list is, if a student drops a ball from the top of the building, V initial is 0. Let me fix that. Equals 0 meters per second. So V final is our question mark, but that means V initial equals 0 meters per second, and V final is a question mark, height is a question mark, and time is given, 2.85 seconds. So time of fall is 2.85 seconds. Okay, so to reach the ground, determine all the unknowns. What else do we know about a falling object? Well, the fact is, acceleration is g, which is equal to negative 9.81 meters per second squared. And it's negative because it's downward, and velocity initial is 0 because, well, it's not, doesn't have any velocity vertical. And then V final is going to be also negative because it's pointing downward. So we can figure out V final, question mark, as this is the first question. What was the ball speed just before hitting the ground? Well, V initial, time A, and V final comes from the equation A, acceleration, is V final minus V initial over T. So we have V final is what we're solving for, AT, so we'll rearrange, multiply both sides by T. This cancels with this. Now we have AT equals V final minus V initial. Remember, V initial is 0, so this is just nothing. Okay, so AT is V final. So A is G, GT equals V final. Well, this is going to work out handy because G is negative and then V final will be negative. So negative 9.81 times T, which is 2.85 in my situation. Let's see here. 9.81 times 2.85 equals 27.96. So V final is 27.96, negative 27.96 meters per second squared. Or meters per second, I'm so sorry. So V final velocity is meters per second. So what was the ball speed just before striking the ground? That would be, and then I don't remember if this is going to need a negative number, or if it says speed, that might imply that there's no negative necessary. So this is going to be 27.96, and this is going to be meters per second. And then what was the height? From what height was the ball dropped? So now we know V final, and then height is an interesting one, because height can be found a couple different ways. One easy way is to think about the average velocity. Average velocity is equal to V final plus V initial over 2. And since we know V initial is 0, that's nothing. So basically half of V final, which we just figured out. Let's just say right off the top, let's just call that 28. Oh, even though it's not, we're going to pay attention to 27.96, but let's just rough it in here. V final is 28 divided by 2, so it's going to be about 14. And that's equal to the distance over the time. and the distance is all vertical, so I like to call vertical distance height. So the average velocity is 27.96 over 2, so it's roughly 14, is equal to height over time. Well, the time it falls, 2.85 seconds. So 2.85 seconds times 14 meters per second. And then seconds cancels, and now we have meters. So that's not quite 42. So I'm going to go ahead and put 27.96 divided by 2. Turns out to be 13.98 times 2.85. And that's equal to 39.84. 39.84 meters. So it's important that we make a list and use the list to determine which equation we're going to use.